the art and science of wire drawing die matching, how to efficiently create perfect metal wires. Hi everyone, I'm Penny. Did you know? From the smartphones in our pockets to the various tools we use in daily life, countless products rely on an unsung hero, metal wires. But have you ever wondered how a thick metal rod transforms into a slender yet strong metal wire? This magical journey is hidden within a precise technique called wire drawing die matching. What is wire drawing die matching? A high-efficiency slimming plan for metal wires. Simply put, wire drawing die matching is like a tailored high-efficiency slimming plan for metal wires. Its goal is to design the most perfect path, allowing a metal rod to be drawn through a series of dies to precisely achieve the desired thickness, performance, and quality. This isn't just about brute force pulling, it's a comprehensive science that combines material selection, process planning, data calculations, and real-world experience. Core challenge: the invisible slip that determines success or failure. Imagine this: the power wheel of the wire drawing machine, called the capstan, rotates at a fixed speed ratio, but as the metal wire is drawn thinner, its forward speed keeps increasing. The speed difference between these two creates a critical parameter, the slip coefficient. This coefficient is like the accelerator pedal when driving. If controlled just right, the metal wire forms smoothly and efficiently. But if mishandled, it could lead to scratches on the wire surface at best, or at worst, a broken wire, or even scrapping an entire batch of products. Mastering this precision is where engineers showcase their expertise. 3 classic die matching methods, the crystallization of engineering wisdom. So, how do engineers cleverly tackle this challenge? Beyond relying on the experience passed down by seasoned craftsmen, the industry has developed 3 classic theoretical methods: absolute slip coefficient method, J method, stable flow method. This method is akin to the law of conservation of mass in physics. Its core principle ensures that the volume of metal passing through each die per unit of time remains constant, like a river with a steady flow, enabling the most continuous and stable production. Traditional theoretical die matching method, C method, reverse engineering method. This is a brilliant reverse engineering approach. It starts with the desired final product, the thinnest wire, and works backward to calculate the die sizes for each step. By setting a clear target first, it reverse engineers the path to achieve it. New theoretical die matching method, X method, ultimate performance method. This is the top-tier player in the world of die matching, aiming for zero-error production. Its goal is to minimize unnecessary slip while ensuring absolute safety with near-stringent demands on equipment precision, die tolerances, and operational expertise, making it a benchmark for precision manufacturing. Conclusion: an art that blends science and experience. So, as you can see, behind a single tiny metal wire lies the perfect fusion of mathematics, physics, and craftsmanship. No matter which method is used, the ultimate goal remains the same: to efficiently and stably produce high-quality metal wires that meet various industrial standards, providing the most solid material foundation for today's high-tech world. I hope today's sharing was helpful. I'm Penny, and I'll see you next time.